A few weeks ago, I started learning about smart contracts and I launched a new smart contract series on YouTube, and it raised a lot of different questions. If you haven't seen the previous four, go back into my channel. I'll also link them down below. Watch all the four episodes, come back, pick it up from here. But if you have seen them, it raised a lot of questions. I felt like we dove right into looking at vulnerabilities and we kind of skipped some fundamental things that we should have looked at from a hacker's perspective. So I'm bringing back the smart contract series. In this episode, we're still going to look at some vulnerabilities. We're going to take a step back and look at an adversary mindset and how you can actually approach a smart contract in order to exploit them. So that includes things like doing a threat model, understanding these different functions, and then later on looking at an example. Again, just like those past four episodes, I've partnered with Halborn again, and I have Pablo joining me. So I'm just gonna shut up, roll the clip, and let Pablo explain all this stuff, and maybe we can learn from him directly. Hi Pablo, thanks again for joining me. Before we jump into this episode, I want to say thank you for taking the time to come on here again and help me with the smart contract. I think I've learned some stuff so far. I haven't found any bugs yet, but I've learned some stuff. Before we jump in, people that haven't seen the last episodes, give me a quick background on who you are and what do you do at Halborn?
Yeah, sure. Well, first of all, thank you very much for having me here again. And I'm Pablo Gomez. I am a security, offensive security engineer in Halborn. So my daily work is to audit smart contracts and work with blockchain in general. I have a background in IT, in regular IT, but right now I'm focused since 1 year ago. I'm focused only in blockchain, well, and a little bit of mobile applications, but
Nice,
not so
very
much.
cool. So last time we did four episodes. We talked about smart contracts. Just a quick refresher on what smart contracts are. I think the way I look at smart contracts is that a smart contract is some sort of like an if-then statement. If something is met, then something else happens. I know that's not exactly how it's supposed to be described, but can we do a quick review of what is a smart contract and why is it called smart?
Yeah, well, I think it's a good approach that you mentioned, but I would say that one of the key points of the smart contract is that it is a distributed program. So it's not centralized in one node or whatever, but it is distributed. So it is being executed by all the blockchain. It's a tricky concept, but is in that way. And the smart contract is the only thing that well the all the things that the smart contract does is to automatically manage transactions between users, protocols, and manage money at the end. So it's sometimes it is based on if else sentences, but I would say that a lot of if and else sentences creates a bigger picture of that.
Yeah.
Mhm.
So, like I come from a web background. I do a lot of, I've done a lot of bug bounties. Web is a little bit different, but when I approach a company, even if it's a pen test, red team engagement, whatever, I do some sort of threat model. I look at what this company looks like, what is considered a threat for every company is different. Some companies they store PII, that's the gold mine for them. Some companies don't. Is that similar to when you look at a smart contract? Can you do a threat model for a smart contract?
Yeah, well, it's kind of similar, but what I have seen in my experience, and I guess in all my colleagues' experience, in when auditing the smart contracts, is that every protocol is very very different from another. So
Yeah.
you have to understand the how the protocol is working, not only the technology, because of course you have to understand the technology and you have to know what are you doing and how to find the bugs, but you have to study a lot about a specific protocol which is using one technology in particular. So
Yeah.
I would say that maybe you have to focus on I would say simple operations sometimes, because most of the protocols the simplest operations are not controlled sometimes. I mean, for example, arithmetic operations, or
Yeah.
for example, I would say just deposit, just deposit one ether or something like that, or just withdraw just one token about something, and and yeah, and have extremely caution when uh, when auditing and when trying to find bugs in operations that are managing money directly. I mean,
Yeah.
withdrawal functions, swaps, breaches, all of that.
So let me give you an example. I mean, I always go to a web because that's like the area that I'm comfortable with. Like
Yeah,
when I do,
go ahead.
so my process with web applications, I do recon. I understand what applications are hosted, and my threat modeling for the company is depending on what the company looks like, right? If a company has an internal environment, or internal permutation of like applications that could be internal, whether it is their, their the CI/CD pipeline, whatever this is, right? I prioritize those. When it comes down to
Mhm.
looking at a smart contract, would you say that the functionalities, the different functions, are how you a threat model for them? Like, do you look at, this function handles how, money is being transferred, or how being money is being borrowed? Is that how you threat
Yeah,
model? How do you? Is that how you
yeah,
prioritize them?
yeah, that's right. It is a little bit complicated because everything has to be in common with every function has to be something with other function. But I would say that a good approach is to start first of all, try to follow the execution flow, because you have always an entry point in the smart contracts. This is not like a web recon. You are not
Yeah,
getting like 100 of webs. You have only 4 or 5 or 6 or 10 entry points that you can focus on. So the first thing I would say is that go check in function by function, what are they doing, and have extreme caution also, as I said, with the functions that are managing directly money. For example,
yeah,
uh, as I said, withdrawal functions, or some functions that has tricky names like start auction, for example, deposit or withdrawal, or change ownership. The main objective of a smart contract auditor, I would say that it is not to uh, gain remote access, because you can't gain a remote and RCE, but to steal funds, to create DOS, to exploit in change ownership of the contracts. That would be the objectives,
so
and
yeah, so
yeah.
an adversary's goal would be, I just want to kind of wrap up in like do a, a review of it. So an adversary, if I wanted to completely own a contract, would be denial service, so no other people can access the contract. It would be pretty much
Mhm.
drain the funds in some way,
Mhm.
transfer the contracts to myself. Um,
Well,
is
it
there
transferred
anything,
the ownership of the
the
contract,
ownership of contracts to
maybe.
yourself?
Yeah.
So those would be the absolute worst case as somebody who, as an adversary who wants to go after a smart contract.
Hmm. Yeah, that's right. I would say so. Maybe I'm missing some use case, but
Right.
but I would say so. Yeah.
So one of the biggest things that people ask me, when it comes to smart contracts is, how do you even approach the testing? Like, how do you, how do you look for a way to transfer the ownership of the contract to yourself? Or like, how do you even, drain a contract?
Hmm. Well, as I said, first of all, you have to understand how it's working, and
Yeah.
sometimes it's quite difficult because every protocol is managing. Sometimes, well, most of the times, complex financial concepts. So you have to study, you have to review the white paper of the protocol. First of all, you have to review GitHub and see what is happening. Of course, you have to do that in regular book bounty. But
Yeah.
in this case, I would say that you have to know uh, there are maths implicated in this study. There are a lot of financial concepts that you have to review, and of course prepare the environment, because these environments are not as, I would say, as straightforward like others. You have to
Right.
prepare your local network in order to deploy the contracts, to start to compile the contracts, and to create a POC. And yeah, you can review the code directly, but the best way of trying to find bugs in these contracts is to prepare your setup, your environment. For example, I'm using VS Code with some plugins, and for example, in Solana I use Cargo, or for example, in Ethereum use Brownie or Ganache.
Yeah.
Um, you have to prepare your environment, and then, as I said, go, no rush, go step by step. Try to find the entry point. Try to go testing function by function. This is a very manual approach, because you don't have the traditional automatic tools to do this, and you will have to go function by function, trying to find what is happening. And the first, well, and the following step, I would say that prepare a POC that is working appropriately. I mean, prepare just a testing program, just to know how the protocol is working. Like, for
Yeah.
example, if the protocol allows you to create a pool, and then deposit funds, and then withdraw funds, just do that. Just
Yeah.
you don't have to go any farther by now. And then when you have everything working, and you understand how the protocol is working in deep, start trying to mess up with parameters, with public keys, like with everything. But first of all, I think it's very, very, very important to have something normal running.
Okay. That sounds great. So I think the biggest thing everyone's going to want to see is an example.
Mhm.
Do you have something we can show that kind of goes along with what we just talked about?
Yeah, sure. We can. Well, first of all, I would say I would like to introduce you the ERC20 standard. It's
Okay.
which I think it's it's relevant for the example that we're going to see right now. The
Okay.
ERC20 standard is the one related. It is called ERC because it means Ethereum Request for Commons 20, which is the definition of the tokens, the tokens in the blockchain in Ethereum. They are defined using this standard. So I would say that I don't know if we can explain what is a token, but a token, just in a nutshell, you can see it like a ticket of everything. Like, you can vote with that ticket, you can play lottery with that ticket. It depends on the protocol, or you can buy
Yeah.
things with that ticket. We can, in with the using the ERC20 standard, we can mint tokens, we can generate, we can I would say produce these kind of assets. We can burn them, we can transfer them. Okay, we can do a lot of things. So right now, with this background, I think we can see something.
Cool. Let's see it. Cool. So this is what is this? We're here on an ERC20 called Naham. Okay.
Yeah, that's right. This is in your honor. So
Okay.
the thing is that here we have a smart contract. Okay, this is a smart contract. You can see it. It is pretty simple. Okay, it has a name, symbol, decimals. We're not going to go uh, so much farther with all of these things, but I want you to check this interface. Okay, this
Okay.
interface, I would say that this is the ERC20 definition. It's not secure. Okay, this is just an example, so please don't use this to develop anything. Okay, but
Okay.
this definition, as you can see, it defines functions that we can use, okay,
Yeah.
and we can implement just to follow the standard: total supply, balance, transfer, allowance, approve. Okay, and here in this contract, as you can see, it is implementing this interface. Okay, here
Okay.
contract. This contract is implementing this interface. So we have here a lot of functions. Okay, transfer, approve. These functions, I'm saying it again. These functions are not secure. Don't use these functions as you are seeing them. Okay, but we have here. Um, Let me just. Uh, okay, here transfer from. Okay, so what we are going to do, as you can see here, this is commented. Okay, so
Yeah.
when you want to transfer, being a user, you want to transfer tokens from one user to another. You have to, if you want to transfer tokens from other user, you have to ask for allowance. So please, user, can I transfer your funds to whatever, to me or to, I don't know, a
As like a
friend or
permission. You're asking as a permission, you're saying.
yeah, that's right. This is
Okay.
like a permission. But sometimes, if you implement these kind of functions wrong, um, you are going to be able to steal the funds, to steal the tokens. Why? Because you are not taking, for example, this allowance. Okay, so we can see it here. I have developed just a simple function. You are going to see a lot of prints. Okay, don't worry about that. And we are going to execute it using Brownie, which is I would say it's a tool that can compile these contracts and also can execute them and execute test scripts. In this case, we are using Python, okay, which is
Okay. Just
the
sorry, if you're watching, we're gonna use Brownie to compile this. If you haven't seen them, go to the last episodes. I think episode 2 of this series, we talked about this on how to use Brownie and some of the other tools. But what Brownie is, it's gonna compile the contract and then you can essentially run it, right?
yeah, that's right.
Okay.
So okay, as you can see, they are compiled, and now we can use this instruction, okay, test, to execute this test minting. So as you can see here, okay, this warning message, don't mind about that. So as you
Okay.
can see here, payer minted 250, user minted 100, and attacker minted 0 tokens. And
Okay.
now the payer has 150 and the attacker is still 100 tokens. So as we haven't developed the function correctly, we are allowing anybody to steal the tokens. So this is a critical vulnerability.
So that essentially means you're just stealing from other people without the permission.
That's right. That's right. Because you can move the tokens as you will.
So if like a developer is doing something similar, they're developing a smart contract, how do they prevent this?
Just have in mind, okay, just the functionality of these functions, okay, how they are working. So here we can, well, usually when we audit something, and you know that we don't give direct recommendations because it is dependent on the developers. It depends on the
Yeah.
developers, but you can follow the ERC20 standards, and you can use. I have it here commented. You can use, for example, these imports. Okay, which right now is not important because it's not connecting well. But you can
Yeah.
use this kind of imports, which is from Open Zeppelin directly, and you have the ERC20 specification solidity contract. So you can call it, and you don't have to implement your own ERC20 contract. You
So
know,
you essentially are just using a library to just implement on top of it instead of reinventing the wheel on your own and making a
yeah,
mistake
that's
like
right.
that could pretty much steal from other people's contracts or you could some other people's tokens. Okay, cool,
Mhm.
interesting. And is this has this is this based on a true scenario? Has this ever happened to any? We don't have to name any contracts or any tokens, but has this ever happened in real life?
Yeah, well, this usually happens when well, to be honest, right now I don't have any uh, any example about
You're
that,
right.
but yeah, but yeah, for sure, you can have. maintain vulnerable maintain functions, or not just the function, not just one function, but the complete ERC20 contract.
Is it safe to say, for let's say if this were to happen in real world, the essentially what they can do is they could be draining everybody else's tokens without them even knowing. So they could pretty much exploit this in a way that it's continuously happening to everyone using this contracts and draining their wallets or whatever, right?
Yeah, that's right. In this particular scenario, I would say that well, it's pretty easy to realize that this is vulnerable. So I wouldn't say that this exactly scenario is going to happen, but of course, any related scenario
Yeah.
regarding this kind of minting or transferring tokens, this usually happen. Yeah.
That's incredible. So this is an example of something that could go wrong with minting. I think there are other vulnerabilities that we've talked about. We're not going to cover them in this episode. I think the next few episodes we're going to talk about logic phones. I know we did some sort of a demo in the past, but I think there's more to it. I think there's something about technology-specific phones. I'm really curious to know what that is. And then I think the next one is also authorization phones. And these are
Yeah,
coming up in the next episode, right?
that's right, and we will see. We'll try to put an example of a reentrancy attack, which is pretty interesting.
Cool. So no spoilers. We're gonna keep those on the next episode. Again, Pablo, thank you so much for joining me. This
Thank
is very,
you.
very cool. I'm starting to learn a lot from you guys, especially from you. Thank you for doing this. And we'll see you in the next episode.
Awesome. Bye.
All right, that's it. That was episode 5. Leave me a comment down below. Let me know what you think. Let me know if this is something that you have came across. We're going to go look for. What do you think? Do you want me to make more of these videos? And then come back next week for episode 6, where we talk about reentrancy vulnerabilities. And I think, if I'm not mistaken, we're going to find out next week, but this is how about 50 million Ethereum was hacked, something like that. We're going to come back and find out.